Okay, let's switch gears and let's talk a little bit about white blood cells. Now we'll talk a lot more about their specific functions when we get to the immune system, but let's do an introduction here. White blood cells, also known as leukocytes, are nucleated, meaning they do have nuclei, unlike red blood cells. However, they do not contain any hemoglobin. There are two major categories. You either have granular ones or agranular ones. The granular ones are so called because they look like they have like little grains or granules in them. The three different ones are basophils, eosinophils, and neutrophils. The agranular ones are your lymphocytes and then monocytes. You don't have as many white blood cells as you do red blood cells, and don't worry about memorizing these numbers. These are just there for your information. At any given point in time, about 2% of your total number of white blood cells is in circulation. And I really like this image because you can see these white blood cells, and in fact, instead of kind of being free floating around in a blood vessel like red blood cells, they tend to move right along the walls of the blood vessel, and this will become very important because they're going to pick up on cues that there's damage somewhere and then squeeze through those blood vessel walls. So they do that by rolling along like the walls of the blood vessel itself. We'll talk a little bit more about that later too. As far as individual white blood cells go, basophils are going to leave the capillaries, and they will release granules. Again, they're granular white blood cell that contain heparin, histamine, and serotonin at sites of inflammation. These are going to intensify your inflammatory reaction, and these are the ones you get to thank for your allergies. So yes, you may hear it in my voice as well. My basophils are responding to pollen, going, oh, we have got to release all of this histamine, which causes an inflammatory response. So that's how you get like, like the puffiness, the stuffiness, all of that kind of stuff. Things that would normally trap an infection, think of it that way, it's responding to something like pollen that actually won't harm you. This is also why you may take antihistamines to combat your allergies in the spring. Eosinophils also will enter the interstitial fluid. These will release histamine ACE, so that ASE indicates that it is an enzyme that breaks down histamine, so it helps try to control what the actions of the basophils are. They also phagocytize, so they gobble up antigen-antibody complexes. Now, the ones that we've talked about so far are the red blood cell ones, but as we talk about it in the immune system, your immune cells will also produce antibodies against bacteria and viruses and different things like that. So they will also gobble up anything that might be caught by antibodies. And they're also effective against certain parasitic worms. So all these like little eosinophils will kind of gang up on a parasitic worm. It kind of almost looks like ants attacking like a larger thing and gobble it up. Now, in this image that you're seeing here at the top, this is an eosinophil. It has this sort of traditional two lobes attached by this thin little bridge. This below is actually a neutrophil, and you can see it kind of has that very similar one lobe, tiny little bridge, but you see how like misshapen the second lobe is? That's how you know it's a neutrophil. Most things that you will see underneath the microscope are these neutrophils. They are much more prevalent. However, and some of them will have a really odd shaped nucleus. However, some will try to masquerade as eosinophils. And let me just be very clear. When I say they try to masquerade, they're not actually trying to do that. It's just visually, it's easy to confuse them sometimes. This image here is more your typical neutrophil, where we have this crazy multi-lobed nucleus appearance to them. Neutrophils, along with macrophages, are phagocytes. So again, these are going to go around gobbling things up. They are attracted by chemotaxis, meaning that there is a chemical that is being given off either by the damaged tissue or the invading microbe that attracts them. Neutrophils are are one of the smaller white blood cells, so they respond very quickly to tissue damage, and they will use lysozymes, oxidants, and defensins to kill the bacteria. Lymphocytes are one of the main soldiers of the immune system, and we're going to talk a lot about lymphocytes. They kind of have this, I don't know, fairly circular, dark nucleus that takes up most of the cell. They come in the variety of B cells, T cells, and natural killer cells. Again, we're going to talk a lot about B cells and T cells when we get to the immune system. But in general, B cells will destroy bacteria and inactivate their toxins. B cells will also become plasma cells and produce antibodies. T cells, on the other hand, will attack, you can see this, viruses, fungi, cancer cells, transplanted cells. So this is why people who have had received an organ from someone else, they have to be on immunosuppressant medication to help suppress these T cells so that the body does not reject the transplanted organ. What's happening when the body is rejecting it is these T cells are recognizing that it's not you, it's foreign, and they are attacking it. And the natural killer cells will also attack a wide variety of microbes and even some tumor cells. Monocytes are the largest. They are very large macrophages. Because of their size, it takes them a little bit longer to get wherever they need to go, but because of their size, they can gobble up a lot more as well. So here's your typical monocyte. So how do the white blood cells know where to go? Well, there's a process. Remember when we talked, I was just mentioning to you just moments ago that they basically roll along the walls of the blood vessel. Well, they have something on their cell membranes called an integrin. When there is tissue damage in this area, so let's say there's tissue damage over here, the walls of the blood vessel will insert something called a selectin. So that selectin and the integrin, you can think of them as two sides of Velcro. So if there's no damage, there's no selectin on the walls of the blood vessel, and the white blood cell simply rolls along. In those areas where there is damage, these endothelial cells, the cells of the blood vessel wall, will selectively put in these selectins, and then it's like the two ends or two sides of Velcro. That white blood cell, as it rolls along, sticks, and by sticking, that triggers the response to squeeze through the endothelial cells and follow that chemical cue to wherever the infection might be. So that's a high-level overview of our white blood cells. Hopefully that makes sense to you. Again, we'll get into a lot more details on our immune system in a couple of modules. All right, so let's just talk about what can go wrong with white blood cells. Just like our red blood cells, we can have high and low counts. So leukopenia is a decrease in the number of white blood cells. That's your definition. You don't have to worry about the actual numbers. I won't ask you that. But please be aware that the term leukopenia is a decrease in number of white blood cells. So things that may cause that, some cancer treatments, diseases of the liver or the spleen. Sometimes emotional or physical stress can also do that. Leukocytosis is just the opposite. It's an increase in the number of white blood cells. Again, you don't need to know the number. Just be aware of the definition. Sometimes you'll see an increased white blood cell count if there's an infection. Some of these will increase in response to medications, as well as leukemia, right? Where there's just a very large amount of white blood cells in circulation. This makes sense, and then what you'll see a lot of times in like blood tests is they're actually testing for the specific types of white blood cells because that can help determine what type of infection it is. Now, leukemia is, it can come in an acute and chronic variety. Basically, the acute is an uncontrolled production of immature leukocytes. You can see that in this image. They crowd out the red bone marrow cells and hamper the production of red blood cells. And obviously that's bad, right? There's also a chronic one. It's not so much that you are producing too many, but you're accumulating too many because there's not that natural cell death going on. So again, the end result is the same. You have too many white blood cells. It's just how you get there is a little bit different between the two. And then you'd classify a type of leukemia by the white blood cell that is the one that is predominant, so monocytes, lymphocytes, etc. You may have heard of stem cell transplants. But we're talking about our bone marrow transplants. So usually they'll take bone marrow from the hip because it's fairly superficial and transplant it via blood transfusion to the recipient, and that helps repopulate the bone marrow. There's also cord blood transplants. So you can see the stem cells are obtained from the umbilical cord shortly after birth. They can be stored indefinitely. And then the good thing about cord blood transplants is that they're less likely to cause something called graft versus host disease. So what graft versus host disease is it's kind of the exact opposite of when a body rejects a transplanted organ. So we just said, let's say I receive a donated kidney from somebody else, there's a possibility that my body will not accept it and will reject that kidney, right? Basically try to destroy it. In graft versus host disease, in that bone marrow transplant, sometimes the graft, that bone marrow, starts attacking the host. So instead of the host rejecting the graft is rejecting the host and trying to kill off the host because it sees the host as foreign. Obviously, very deadly. So you want to try to avoid that at all costs as well. All right, so hopefully that makes sense. And we will, again, talk more about white blood cells and their functions when we get to the immune system.